Warning, the video you're about to watch contains mathematics at the level of integral calculus, also known as Calc 2. All material has an assumed prerequisite of differential calculus and a full semester course in trigonometry. A thorough review of prerequisite topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is for Calc 2 students who are in the middle of partial fraction decomposition. And I generally do not like to do a ton of these examples in class because they take a long time. And there's just a lot of algebra in the background that's prerequisite, you should already know, but it's good to kind of see it fully worked out. So I appreciate being able to do that for my students in this format. Taking a look at the integral we've been handed, it's pretty obvious that a u substitution is not going to be helpful. But something else that should be pretty obvious. The power of the numerator is greater than the power of the denominator. So this is a rational function. So I'm immediately thinking that maybe partial fraction decomposition might be worthwhile to look at. But the thing that's stopping me from doing partial fraction decomposition is that the powers here are not correct. So for partial fraction decomposition to work, we need the degree of the numerator to be strictly less than the degree of the denominator. It cannot even be equal to. You have to do some type of either synthetic division or long division. In this case, I'm just going to perform long division. Well, actually, you could do synthetic division here if you wanted to. Synthetic division tends to be faster anyway. So if you want to see this using synthetic division, might as well. Because I do long division in class, I might as well just do synthetic division here. The first thing you need to do if you want to do synthetic division rather than long division is to factor that denominator. The problem with using synthetic division is that you have to be pretty adept at it to really use it well in a problem like this. So if you're not comfortable with synthetic division, I highly recommend switching gears and going back to long division, just because, well, it's probably better to do that. But I'll go ahead, like I said, and perform synthetic division. So there, if x minus 3 is the factor that I'm trying to divide in, I will do synthetic division by 3. And the coefficients of x to the 4th and x to the 3rd and so on and so forth in the numerator are 1, -5, 6. Let me at least write those down. 1, -5, and 6. That would be 4th, 3rd, and 2nd powers. Then we don't have a first power in x, so that'll be 0 and then a -18. Bring down the 1, multiply that by 3, place it right here. Add those two together, -5 plus 3 is -2. Multiply that by 3, you get a -6. Add those two together and you'll get 0. Multiply that by 3 and you will get 0. Add those two together, you get 0. Multiply that by 3 and you'll get 0. Add those two together and you'll get a remainder of -18. What does that mean? Well, remember, this was the 4th power right here on x. So we have reduced the overall power of this polynomial in the numerator by 1. And we get the following. We still have an x squared in the denominator, so there is a little bit of work there. And then the rest of it's actually pretty easy. We get x cubed, 1x cubed, sorry, and a -2x squared. And let's see, 0x and a 0 for a constant, and then you have -18 over that divisor of x minus 3. It doesn't really do a lot, it looks like, but it actually does. It does quite a bit, because when you do this, you see x squared goes into x cubed, x times, x squared goes into x squared, well, once, and then you have -18 over x squared times x minus 3. That actually worked out pretty quickly. If you had done long division, on the other hand, you would ask the same questions that you would normally ask when you're doing regular old division. How many times does x cubed go into x to the 4th? Well, it goes in x times. Check your work. X times x cubed is x to the 4th. X times a -3x squared is a -3x cubed. and then you would subtract that entire statement. X to the fourth minus x to the fourth, they cancel by design. Negative 5x cubed minus a negative or plus 3x cubed is a negative 2x cubed. And then you could, if you wanted to, bring down the other factors or the other terms. There's no real need to do this, but I'm just showcasing it. And then you would ask yourself, well, how many times does x cubed go into negative 2x cubed? That goes into negative 2 times. Multiply back through, you get negative 2x cubed plus 6x squared, and you'll subtract that entire statement. The negative 2x cubed minus a negative 2x cubed, those cancel by design, but luckily 6x squared minus 6x squared, those cancel as well, and then everything else just gets brought down. And here is what our remainder is, and you get to the same factorization. X minus 2, and then minus 18 over that fraction. Notice this, or over that denominator. Notice this numerator has less power or less degree than its denominator. Denominator has degree 3, the numerator has degree 0. At this point, you can actually integrate the first two terms. And from this point forward, it's actually just back down to using our partial fraction decomposition, decomposing this so that it's a split of 3 different fractions. So in blue ink here, I'll go ahead and just write my work. 1 over x squared times x minus 3 is equal to some number over x plus a different number over x squared. Remember, each linear factor has a representation all the way up to the power of that linear factor. That is, this linear factor of x has a power of 2, and so I'll have a fraction with a power of 1 with that linear factor and a fraction with a power of 2 on that linear factor. If that was a power of 12, then I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those fractions adding up, which would be a pain, honestly. And then we have an x minus 3, so plus c over x minus 3. And if you don't know the tricks, I'm not going to teach you. Instead, I'll just multiply both sides by the LCD. Now, recalling what I teach to my students, we're going to start solving this by first making a strategic substitution. A strategic substitution is basically saying, I know a good value of x to plug in. This equation should be true no matter what I plug in for x. So I'm going to go ahead and let x equals 0 because that will turn this term off and this term off. So doing that, I get the following. 1 is equal to b times a negative 3. So I already know what b is. B is a negative 1/3. Another strategic substitution is x equals 3. Again, because when you plug x equals 3 in, the first two terms will turn off. This guy will turn to 0, that will turn to 0, and so the only survivor will be that last term. We get 1 is equal to 3 squared times c, or 9c, which implies 1/9 is equal to c. We are in luck because now all we have to do is choose another value for x. Again, this equation at the top there is true for all values of x. Well, I've already plugged in 0 and 3, I'll just plug in 1. And at this point, you have to use the values of b and c that you had earlier. So 1 is equal to a times 1 times 1 minus 3 plus b, which is a negative 1/3, times 1 minus 3 plus c, which is 1/9 times 1 squared. Notice that equation only has one unknown and somewhat simple to solve. So let's go ahead and solve that. So there we have it. We have a, b, and c ready to go. So now I will go back over to my integral that's all the way up there on the right edge of the page, the upper right edge of the page, and split out that fraction. We'll start that. And now we see this is going to be a pretty simple integral at this point. Probably the biggest mistake I will see people make is the antiderivative of this right here. That's x to the negative 2, and you raise that to 1 by 1 power. So it's x to the negative first divided by the negative 1. It's just something that people often screw up, so be aware of that. Now I'm going to do some distribution. And as I tell my students in my calculus class that your answer might look slightly different than mine. So if specifically you wish to combine these two logarithms, you totally can. However, just letting you know that honestly, that could in the long run cause some issues, but because we have absolute values, it won't. So don't worry too much about that last statement. I'm just going to rewrite it like this. So all I did was use properties of logarithms. I pulled the powers into the exponents here, or the coefficients in the exponents, and I also combined the two logarithms. Natural log of a minus natural log of b is natural log of a over b. And one other thing I should mention here, because of this, you actually do not, because I have squares on those exponents, you don't have to have the absolute values. You could take them off if you wanted to. All right, so that's a good example and a reminder that to use partial fraction decomposition, you must have the degree of the numerator strictly less than the degree of the denominator. To accomplish that, usually people are going to use simple long division. However, you're not restricted to that. You can totally use synthetic division because it's pretty awesome.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Just listen close. Don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.